Okay, let's do some homework on page 384. It's chapter 8.7 where we learned about the possible rational zeros test. So when they ask for the list of possible rational roots, you're not solving anything, okay? But you're remembering the rule that the list of possible rational zeros is equal to factors of the last over factors of the first. Okay, let me explain what I mean in case you don't remember. When I look at the last number, that's a 6, so 6 is going to have factors of 1, 2, 3, and 6. When I look at the first number is really a coefficient in this case is a 1. And it is its only factor. So the list of possible rational zeros is going to be plus or minus, which is what I forgot to put over here, the factors of the last, 1, 2, 3, or 6, over 1. Do I need the over 1? No. So it's plus or minus 1, 2, 3, or 6 for an answer. Let me try another one and show you how this works. When you have a number in the front, that would be something like number 7, so you should be able to do 3 and 5 quite easily. Number 7, 2x cubed plus blah 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 minus 5 is equal to 0. I don't care what's in the middle, so I didn't bother to write it out, but my list of possible rational zeros is going to be, the last is this minus 5. I'll do plus or minus 5 or 1. That's the factors of the last, over the factors of this first number 2, 2 and 1. So if you wanted to list them out, you'd have plus 5 over 2, minus 5 over 2, plus 1 over 2, minus 1 over 2, and then you'd have plus 5, minus 5, because those would be the over 1s, and finally plus 1 and minus 1. And that would be a good answer. In fact, I accept this first one as well. Okay, looking on page 384 again, number 23, I'm just going to use this possible rational zero test to kind of know where to get started, or possibly get started, solving this equation. But before I do that, I just want to do a trick, because we all hate fractions, at least you guys do. So I'm going to just multiply everything by 6. Because I had a 3 in the denominator and a 2, that least common denominator will be 6, and I want to lose the fraction. When I do that, I get 2x cubed plus 3x squared plus 4x plus 6 is equal to 0. And now you can see things are going to be a little simpler for us because I don't have to deal with the fractions anymore. So the list of possible rational zeros is going to be plus or minus this last number and its factors, 6, 3, 2, and 1, over this first number 2 and its factors, 2 and 1. So I'm going to start with the easy ones first and test them. I'm just going to take all these numbers and start testing them until I get the solution. But there's one other clue I can use. Do you remember Descartes' rule of signs? Well, I'm going to count the number of sign changes. So let me think. Let me change my color. Okay, to go from here to here is not a sign change. No sign change. No sign change. There are 0 sign changes. So guess what? There are 0 positive real roots. So that's a great clue. I'm not even going to bother testing any positives. I'm only going to test negative numbers. So let's start with minus 1, because that's certainly 1 over 1. That's the easiest one to start with. When I test the minus 1, I got my coefficients 2, 3, 4, and 6. Bring down the 2, minus 2, add, multiply, add. Nope, that didn't work. Let's try something else. Minus 1 didn't work. Let me try minus 2. I could try 1/2, but I think I'll stick with whole numbers until I have to go to fractions. Testing 2, 3, 4, 6. Break down the 2, minus 4, add, minus 2, 2, negative 4. Nope. Sorry, that did not get a 0 over here, and this does not get the 0 over here. So neither one of those worked. So let me erase them. And try another number. I can try minus 3. When I have coefficients 2, 3, 4, and 6. Bring down the 2. Multiply, add, multiply. Oh, if this is not going well. 13, no, that's not going to work. Alright. Things are getting worse. I don't think 6 is going to work, so guess what? I'm going to try negative a half. Negative 1/2. Outside. Coefficients 2, 3, 4, and 6. Bring down the 2. Multiply, add, multiply, add, multiply. Didn't work either, because that doesn't work. Alright, let's try another one. Actually, I shouldn't have erased all those numbers. Alright, let's try another number. It's not fun, but you just got to keep going here and trying this. Okay, the coefficients were 2, 3, 4, and 6. This time I'm going to try minus, I could do 2/2, but I've already tried 1, so that doesn't count. So let me try 3/2. Minus 3/2. Okay. Bring down the 2. Multiply. Ooh, add. Multiply. Ooh, add. Multiply. Oh, look. There it is. I found one of the solutions. Is x equals negative 3/2. Great. And that leaves me with x squared. Whoops. 2x squared plus 4 is equal to 0 to find the remaining solutions. I'm going to divide everything by 2 and get x squared plus 2 is equal to 0. Move the 2 to the other side. Our favorite way to solve this kind of quadratic, square rooting both sides. You're square rooting, so you need plus or minus. There's a negative inside, you need the imaginary, and you're left with a 2 underneath. So those are the remaining roots. So if I list them all together, x equal plus or minus I square roots of 2 and negative 3/2. Those would be all the roots. Okay, looking at page 388, this is the oral exercise number 1 asking us to approximate some zeros of this polynomial. It's given to us in table form, so you can see there is no place explicitly where the value of the polynomial p of x is equal to 0. But we know by the intermediate value theorem that it must lie between a positive and a negative number. So look for where it changes signs for your p of x value. And that's going on right here. I'm going from a positive 6 to a negative 4. So somewhere in here is an x value that is a root or a solution to this polynomial equals 0. So I'm going to say approximately between negative 2 and negative 3, negative 2.5. And then I'm going to keep going and look for where else I changed from a positive to a negative. So let's see. Oh, right away. We went from a negative 4 to a positive 3. That's a change. And somewhere between negative 4 and positive 3 is a 0 of the polynomial. So somewhere in here is a root or a solution to the polynomial equals 0. So between negative 1 and negative 2, let's call it negative 1.5 approximately. And then we're going to keep going, looking for where we change from positive to negative. So I'm looking, oh, from here to here. Okay. I went from plus 1 to a negative 3. So somewhere in here is a value of x, maybe it's about 2.5, where there's a 0. Somewhere in here is a 0 for p of x. So this is just a hole waiting for an x value, and this is actually a 0. Okay, somewhere between 1 and negative 3. And that would be my solution. I have found 3 approximate solutions to p of x equals 0. Okay, page 388, number 1, they're asked to draw the graph, approximating about where the real roots of the equation p of x equals 0. So we're going to set this equal to 0 by graphing p of x. And finding the roots of p of x equals 0. So I'm just going to grab a graphing calculator. When you look at it, you've got the buttons at the top, y equals, and you're going to put x raised to the third power minus 16. You're going to do a zoom standard. And you should have a picture that looks approximately, let's see, something like this. Like this. Okay? So you look at this and you say, oh, I see one real 0 right there. So we know there are 3 zeros altogether, so 2 of them must be imaginary. Okay? That's why you only see one real, one x-intercept. So right here, and you just want to approximate that using your trace button. Alright, I use my trace button, and when you're using your trace button, you only use the left and right arrows on the thumb pad to move the snowflake to about where you want to be reading. If you're having trouble finding your snowflake, you might need to zoom out. Okay, so you can always try a zoom, let me check it out, it's a zoom out is zoom 3. Make sure you hit the enter. Sometimes it feels like you have to enter it twice depending on how you press the buttons. So enter, enter, zoom out, and then you can do a trace again. You can find that snowflake. You can move the snowflake left or right. Okay, so once you've done that, you found your trace, you move your snowflake to about where that 0 is, and I'm reading about x is approximately 2.5. Okay?